morning, and what is up, Geo Metro Ninjas? Today, we're going to continue talking about our polygons, and we're going to take a look at our first broadest characteristic of a known quadrilateral. So, the first quadrilateral we're going to talk about is a parallelogram. Now, that's a fun word to spell, but it's an even funner word to say. So a parallelogram is simply a quadrilateral, meaning it's a four-sided polygon in which both pairs of opposite sides are parallel. So this definition really should say, let me find my little box down here. This definition really should say both pairs. I mean, maybe that's why it has opposite sides, but both pairs of opposite sides that are parallel, because only one pair of opposite sides, which we'll learn later, is a trapezoid. Okay, so both pairs of opposite sides that are parallel. So the cool thing about parallelogram is we can talk about the parts, vertices, where my sides come together, M, N, P, and Q. When we name our parallelogram, we're going to name it by the four vertices. Remember, oftentimes it's going to be written in alphabetical order. It's not a hard and fast rule, but for the most part, that's what we're going to stick with. Opposite sides are MN and QP. You can kind of see those opposite sides, MN and QP. They're not touching each other. And then our other pair of opposite sides is NP and MQ. So remember, when we see these little arrowheads, those arrowheads signify parallel. So double here, and we don't just use a single arrowhead again because we're trying to help the person that's looking at our work know that, hey, we know that the green segments are parallel and the yellow segments are parallel, and we definitely know since they intersect, they're not parallel to one another. Opposite angles, angles that are across from one another. So you can see N across from N is Q. That is an opposite angle. Same thing with M. M, and then across from M is P. The diagonals are lines that connect opposite vertices. So diagonal NQ, diagonal MP. And then there's a ton of consecutive angles. Consecutive meaning next to. So N is next to P. P is next to Q. Q is next to M. And M is next to N. So all four of those are consecutive angles. And now you're like, well, what do we got to go through all those for? Well, there are properties of parallelograms based on all of our parts. Okay, so some properties of our parallelogram. Opposite sides are parallel. That is the definition of a parallelogram. If both of my opposite sides are parallel, I have a parallelogram. So if we want to, we can label our diagram. So I can go arrowhead here, arrowhead there, and then we can go double arrowhead top. Perfect. Not only are my opposite sides parallel, but we're going to learn that our opposite sides are congruent. So a single tick mark and then a double tick mark. Not along with the opposite sides being parallel, my opposite angles are parallel. So we got one hoop, and then we go double hoop, double. It's not the individual pieces that are automatically congruent, but the entire angle itself. So opposite angles are congruent, which leaves consecutive angles. Remember, that's that M to Q that you can see right at the top of the screen. Those are supplementary, meaning their sum is 180. So these two angles, if you add them together, equal 180 degrees. And then the final rule we have for our parallelograms is that the diagonals, the lines that connect opposite vertices, our diagonals actually bisect each other. The diagonals themselves are not congruent, but the pieces of our diagonal, so this piece would be congruent to the other side. And then the same thing can be true for that diagonal. Okay, so each of our diagonals are cut in half, meaning each piece of the individual diagonal is congruent, not both diagonals to each other. There are figures that have that, but that'll be later when we talk about more quadrilaterals. So we're going to use our properties of parallelograms to help us solve for missing values. So looking at number one, okay, we've got parallelogram ACGF. And if we want to, we can go ahead and highlight our opposite sides. Maybe that'll help us. AF, CG. Okay, so if we're looking at the green AC line, this guy is 10. We know that since it's a parallelogram, opposite sides are congruent. So if the top is 10, the bottom has to be 10. Okay? Same thing, blue AF is 14, blue CG is 14. And then there's one more figure that we know for sure. We know that angle F is 52. And if we go across to F, that means C also has to be 52. So we have 3 out of our 5 answers just based on the given information. How awesome is that? Now, this last piece is a little different. We do not know G and we do not know A. So we're going to have to do a little bit of mathematics to get where we need to get to. So remember that our consecutive angles, meaning F and G, when those two are added together, they equal 180 degrees. So that's the math we're going to do. 52 plus the measure of angle G is equal to 180. And then we're just going to subtract 52 from both sides. So the measure of angle G is 180 minus 52, which I believe is 128. And just because I want to make sure I'm not giving you the wrong information, I'll type that into the L calculadora, and boom, 128. So we know G is 128. And again, because this is a parallelogram, if G is 128, the angle that is opposite of G across from the figure also has to be 128. All right, number 2. Now this time they put the diagonals on us. As always, we're going to start by labeling the given parts. W, X, Y. Remember, when we're given these 3-letter angles, they're giving us the roadmap on how to draw our angle. So we start at W, travel to X, down to Y. So that means this whole angle is 105. For easy's sake, I'm going to go ahead and write that out there so it doesn't confuse me. And then X, Z, Y. Remember, roadmap, X to Z to Y. So we go X to Z, finish at Y. So this vertex is 44. Now, since we know that these sides are parallel, it's going to open up one of our old friends. So if we remember back to the first semester, if we can find a Z between parallel lines, we have our old buddy, D, alternate interior angles. Alternate interior angles are always congruent if we have parallel lines present. In this case, we've got parallel lines because it is a parallelogram. So that's 44. So to find our buddy here, we know that the entire angle WXY is 105. So we're going to take that 105 and subtract the piece that we know of 44. So then we get 61. And then based on the information we have, we can also find out what all of this is, but we don't have enough information to find those little pieces. So that'll have to be another day because we don't have what we need to be able to find that. But we can find the entirety of y. We just don't know how y is broken up. So x and y are supplementary, meaning they equal 180. So we go 105 plus the measure of angle y is 180. Subtract 105 from both sides. So the measure of y is 75. So we know that y has to be 75 degrees, but again, we cannot break these up because we don't have enough information. Now, if I had one of these angles, absolutely, we could find everything we need, but we don't. So let's look at the answer blanks and see if we can use our roadmap to help us figure out which angle they want. So W, Z, X. W, Z, X. Well, technically we didn't find that angle, but technically we did. So remember, these are parallelograms. Opposite sides are parallel, meaning that if that top right corner is 61, my alternate interior angles tell me that that's 61. We could have also remembered that opposite angles are congruent. So if this whole angle was 105, that whole angle has to be 105. And we could do the same thing we did up there to find 61 again. So we know WZX is 61. X, Y, Z. So X down to Y across to Z. So the whole sum of angle Y, which we found to be 75. And then our final one, WXZ, start at W. Well, that was not a straight line. WX, go down to Z. They want this angle, which we found to be 44, thanks to our alternate interior angles. Yeah. So they can always sprinkle some algebra on us, and realistically, they love sprinkling algebra on us, and I personally love doing the algebra part of it. So let's see what we can do. It says find the length of AC and the measure of angle C. So we have a parallelogram because they told us the figures below are parallelograms. So because we know that they're a parallelogram, we know that our opposite sides, AC and FG, are equal. We can write that equality statement. AC is equal to FG. And then we can substitute the given values. So they tell me that AC is 19x minus 31. FG is 11x plus 1. We have a variable on both sides of our equal sign. So what we're going to do is we're going to move that variable first. We're going to subtract 11x from both sides. It's going to knock that guy out nice and easy for us. And we end up with 8x minus 31 is 1. Now that we've got our variable on one side of the equal sign, we can go ahead and move that constant. We're going to add 31 to both sides. So 8x is 32. And then our final step for x is to divide by the coefficient 8. So x is 4. They didn't want us to do x, they wanted AC. So what we're going to do is we're going to take that 4 and we're going to substitute it in. I'm just going to do it right up here so we kind of know where we're coming from. So we get 19 times 4, which is 76. 76 minus 31. Let me go ahead and verify 19 times 4. Trust myself. 76 minus 31. So we know that the length of AC is 45. So we know that's the length of AC. To get what angle C, they give us pairs of opposite angles. Since it is a parallelogram, we know that opposite angles are equal. So we're going to write out that equality statement. The measure of C is equal to the measure of angle F. Do you have to write the equality statement? No. Writing the equality statement will help you keep yourself organized? Absolutely. Take that little bit of time to write your equality statement so then hey, I need to plug in C, I need to plug in F, and it doesn't go sideways on me. So 5y plus 2 is 20y minus 28. Just like last time, we've got a variable on both sides. So we're going to go ahead and move our variable first. Subtract 5y. So 2 equals 15y minus 28. Now that we've isolated our variable to one side, we're going to go ahead and move that constant. So 2 plus 28 is 30. 30 is equal to 15y. And then our final step is to divide by the coefficient. 15 into both sides. So we figure out that y is 2. Again, they did not want the measure of y. What they wanted was the measure of c. So we take the value we found for y, which was 2, and we plug it in to the given value of c. So 5 times 2 plus 12 is 12 degrees. So don't get hung up on the fact that, coach, that doesn't look like a 12-degree angle. Remember, in geometry, unless otherwise stated, we can never assume that a figure is drawn to scale. So we only go based on the information they give us. If the numbers they gave us is that angle's 12, well, we're going to rock and roll with that angle being 12. Number 4, given VQ equals 4x plus 11 and QS is 6x minus 15, find the length of VQ and VS. Let's go ahead and label our diagram with our given information. So VQ is 4x plus 11, and QS is 6x minus 15. We know this is a parallelogram because they told us in the instructions that it was a parallelogram, and one of our properties is that the diagonals bisect each other. That means that VQ is congruent to QS. So based on that mathematical property of a parallelogram, we can write an equality statement, VQ equals QS. And now if you really want to throw back in time, that would make Q technically a midpoint because it's in the middle of V and S. Kind of fun, right? Substitute what we know, 4x plus 11 is 6x minus 15. Variable on both sides, just like before, we're going to go ahead and move that variable first. So subtract 4x, 11 is 2x minus 15. Now that we've got our variable to one side, we can move our constant. So we're going to add 15 to both sides. 26 is 2x. And then now that our variable's all alone, we can divide by the coefficient. So we know our variable, x, is 13. Now once VQ and QS, so VQ is just this, or VQ and VS, excuse me. VQ is just a small line, whereas or VS is the entire line. So what we're going to do is we're going to take that value of x we found, and we're going to substitute it. 4 times 13 plus 11. 4 times 13 is 52. 52 plus 11 should hit me with a 63. If we did our math right, this is a way we can kind of check our work. If we've completed our math correctly, when I substitute this 13 in here over for 15, that should be 78 minus 15. And if we did it right, we should have the same number. And of course we do because we are rock stars. Okay, so the whole length is then 63 plus 63, or 63 times 2, which is 126, not 128, like the goofball teacher wrote. Number 5, they tell us that angle BCD is 120. So BCD, so B to C to D, so that's this whole angle. And it told us that that guy is 120. And they labeled our diagram with ABE being 2x minus 5 and ADB being minus 5. Since it is a parallelogram, opposite sides are parallel. If I have alternate interior angles inside of parallel lines, my angles are in fact congruent. So now I've got one more step, but I need to find this whole measure of ABC first. So this is a two-stepper. So we need to figure out what angle B is using our consecutive angles or supplementary rule. So to do that, we're just going to go measure of angle B plus C, which was 120, is 180, minus 120 from both sides. So we know that that whole angle up there is 60. Then using our angle addition postulate, we know that those two smaller angles add together to create our bigger angle. So 2x minus 5 plus 15 is equal to 60. Combine like terms, negative 5 plus 15 is just positive 10. We don't have a variable on both sides, so we can go ahead and move that constant first. So minus 10 from both. So we get 2x is equal to 50. And then we can divide by 2. So x stops at 25. And that's our answer. So that was a two-parter. It's a little tougher, but we like it. We can eat that. We're good. Okay. Parallelogram PNCL. Diagonals intersect at point B. They tell us that NB is 5x minus 1 and LN is 8x plus 4. So for some of us that spatial awareness isn't really our thing, we can always draw a picture. And then hopefully that showed up as a parallelogram. Look at that. Okay, so P, N, C, L. I just kind of went in order clockwise around our figure. And then we're only worried about NB and LN. So that's this diagonal. And then in the middle of that is point B. So we know that NB is 5x minus 1. We know that LN, so the whole line, is 8x plus 4. So that's the entirety of our diagonal. The whole diagonal is 8x plus 4. So we can't do it like we did number 4 where we set it equal to one another. We've got to get creative. So since we have a piece of a diagonal, we do know that our diagonal is broken up, it's bisected. Okay, so we know that one piece of our diagonal, let's say NB, is equal to half of the full diagonal LN. Because it's cut in half. So we know that that has to be true. So then we get 5x minus 1 is 8x plus 4 divided by 2. Since both of these terms are even, we can do our little butterfly that you guys learned in Algebra 1. And we can reduce. If they weren't both even, I would recommend multiplying both sides by 2. Since they're both even, we can go ahead and reduce. 5x minus 1 is 4x plus 2. We have a variable on both sides, so we need to move our variable first. Minus 4x, minus 4x, x minus 1 is 2. Now that our variable's isolated, we can add 1 to both sides. So we know x is 3. Now, of course, they didn't just want x. They're not going to make it that easy on us. They want LB, which we know LB is equal to BN. So we can just say, hey, if BN is 5x minus 1, LB has to be 5x minus 1, since they're both equal to that. So then we substitute that 2 we found. 5 times 2 minus 1. So we get LB is 9. Now, mathematically speaking, since we found LB to be 9, when we substitute that 2, or that 3, oops, sorry guys, sabotage by Coach O. Just straight sabotage. So we get 5 times 3 minus 1, which is 14. My apologies. Since we know LB is 14, and it's going to be equal to BN, that whole line better equal 28. So that's what we're going to do. We're going to go ln equals 8x plus 4. We get 8 times 3 plus 4, which is 24 plus 4, 28. So, ladies and gentlemen, that is going to conclude our lesson on the properties of parallelograms. Thank you for your time and your attention. Go be great.